Solving multiplication and division inequalities. Our learning target is students can solve multiplication and division inequalities using inverse operations. So the other day we've been working with adding and subtracting inequalities, which was the same as equations. Multiplication and division can be the same thing. This is decisions. Just we have the less than, greater than, less than or equal to, greater than or equal to symbols instead of an equal to sign. Okay. If you need to finish copying that down, go ahead and pause. Otherwise, I'm going to move on to our first example. In our first example, we're going to just check a solution here. Which of the following are solutions of 5x is greater than or equal to 30? Okay, so which of the following are solutions? There might be one answer, there might be more than one answer. Now, there's two ways that we can go about answering that. One, I could just substitute the number in and check. So for example, on A here, I could do 5 times 8 is greater than or equal to 30. 40 is greater than or equal to 30. Yes, so A is correct. And I could do that for B. 5 times 3 is greater than or equal to 30. 15 is greater than or equal to 30. No, 15 is not greater than or equal to 30. 5 times 5 is greater than or equal to 30. 25 is greater than or equal to 30. Nope. We could try 10. 5 times 10 is greater than or equal to 30. 50 is greater than or equal to 30. Yes, 50 is greater than 30. And E, 5 times 4 is greater than or equal to 30. 20 is greater than or equal to 30. No. So the answers would be A or D. Okay, so that would be one way. That seemed to take me a little while to go through and figure them out. The other way, second way, would be to actually just solve this equation. So if I is greater than or equal to 30, I can solve it. Divide both sides by 5. Since I'm multiplying, the inverse operation is to divide. 5 divided by 5 is 1, so I get x is greater than or equal to 30 divided by 5 is 6. So x is greater than or equal to 6. So then I'm just looking for all the solutions that are greater than or equal to 6. 8 is greater than 6, and 10 is greater than 6. 3, 5, and 4 are all less than 6, so that would make that an incorrect statement. So that way is probably a little faster, but either way would be a way that you could check your solution. Okay, if you need to pause, go ahead. I'm going to move on to my next example. Okay, in example 2, solving multiplication inequalities. All right, I kind of went over that a little bit in the last one, so we're going to solve these, and then with all of ours we need to graph them. So first thing I'm going to do is 11f is greater than or equal to 88. Since I'm multiplying 11 times f, the inverse operation is to divide. Remember, I use fraction bars. So I'm going to divide 11f divided by 11. That's going to give me f. The same symbol needs to come down. Be careful of this. Don't put equal sign. F is greater than or equal to 88 divided by 11 is 8. Now when I graph this, I graph my solution for f. This is what I graph. Okay? So you got to make sure that you're graphing the correct result and you're graphing your solution. Okay? Your graph represents all of the correct numbers when I'm shading them in. So I'm just going to put a couple on there so that I can make my graph. Okay? I'm going to circle the 8. Now I'm going to fill in the direction on the ones that make the solution correct. So F represents what I am shading in. So I can try some of these. Okay, 7. Is 7 greater than or equal to 8? No. Okay, is 8 greater than or equal to 8? Yes, so I'm going to fill that in. Is 9 greater than or equal to 8? Yes, it is. So that means I'm going to shade because 8.5, all the decimals, 9, and then beyond, 10, 11, all of those are greater than 8. So I'm going to shade that way and then put an arrow at the end to represent every number greater than 8. Is a correct answer. It doesn't matter if you say 8.1, if you say 100, those are all greater than 8, so those are all correct. The reason I shaded in this circle was because it says the equal to bar underneath the greater than, so 8 is also included in that list. Okay, for B, 7g is less than 91. So again, I am multiplying 7 times g, inverse operation is to divide, so divide both sides by 7. I get g is less than 91 divided by 7 is 13. Graph that solution. Okay, so 12, 13, 14. circle 13. Do not fill it in because it does not have the equal to part. 13 is not less than 13. So then I check, is 12 less than 13? Yes. Is 14 less than 13? No. So I want to shade towards the answers that make this statement true. 12 is less than 13. That's why I shade towards 12. Okay? I'm going to move on to example 3. If you need to pause, go ahead and do that right now. In example 3, solving division inequalities. Okay, so now I'm dividing the variable. So the inverse operation of dividing is to multiply. So I multiply both sides by 4. 4 divided by 4 is 1, so that gives me W is greater than 48. So I'm going to graph this, 47, 48, 49, circle 48. I do not fill it in because it does not have the equal to part. And then I want to shade in the numbers, W, that are greater than 48. So let's test it. Is 47 greater than 48? No. Is 49 greater than 48? Yes. So I'm going to shade this way because these are the ones that are correct. Okay? For B, I'm dividing by 15, so the inverse of division is to multiply. Multiply both sides by 15. 15 divided by 15 is 1. So I get n is less than or equal to 5 times 15 is 75. Okay, now I'm going to graph that. 74, 75, 76. Circle 75. I fill it in because it's got the equal to, so 75 is equal to 75, so that's why I fill it in. Now I'm going to shade in. Is 74 less than or equal to 75? Yes, 74 is less than 75, so I'm going to shade in that way because that is the direction that makes this statement, n is less than or equal to 75, correct. Okay? And that's it. That's how you solve inequalities and graph them. You graph the solutions. If you need to watch any of that again, go ahead. Otherwise, I will see you guys later.